Seems like it's a draft physics video production. DraftScience. You're on YouTube? Anyway, alright, so back to the Michael Van Biezen things, and this subject is going to suck, frankly. Some experiment where they've drawn some wacky conclusion that I think could be reasonably attacked quite easily in terms of what actually took place and what they actually made up as a story for the event. So I thought I would just go over some of the basics in terms of understanding that right from the beginning there's different ways you can look at what's happening in reality, in terms of this interaction thing, kind of understand it in different ways. So they sort of have an understanding that stuff bangs into stuff. This stuff loses its momentum somehow or other. Let's say it changes its frequency or some other kind of thing, but it doesn't. It's something degrades while this goes shooting off, taking this momentum with it. And like you could argue, like kind of like a kinetic reality of cue balls and stuff like that. Pool table kind of reality, maybe. It's kind of Newton, but not really Newton. And I didn't bring any water. Yeah, clever of me. Well, tea will have to do. Here I gotta manage it not to spill it on myself. So anyway, my alternative, as a description of how the thing functions, is that the force bits are plentiful and abundant and all of that. The universe is full of just the two things, the force bits and these two kinds of matter, electrons and protons. And what's really going to happen when they interact is that this electron is essentially made of a bunch of elements of force already stuck inside. So you could think of it a lot of ways, like somehow all their little tails got glued together and they can't unglue them. You could also think of it as they're trapped inside of a membrane, and so they just keep bouncing off the sides. You know, this one bounces off there and it goes back this way, and then it goes back this way, and so it's trapped. So it went in with a certain momentum to the trap. Okay, it came in, say, this way, and it does this other thing. Like, you could sort of see that this was the first arrow, and that these two arrows cancel out, right? I mean, this arrow and this arrow cancel out, and it would keep doing that, but it would never really cancel this initial force. It would always restart the game. So in a sense, this pulses through space in a direction based on what went in first. And so essentially this piece of momentum, even though it's bouncing back and forth in here, it really is this. It's just this broken into ones and zeros. And the one is always there. You can't cancel the one. You can only temporarily reflect and then go back and you restart it again. And then you know, I've sort of explained that. So it's just an interesting physical fact that you could build such a mechanism, that you could build something that had rigid sides, throw something with momentum into it, and in a frictionless world it'll just keep going back and forth. It'll look like it's not going anywhere, but it is going the direction of the initial momentum. And I would argue the Earth's velocity is made out of the same procedure, and such. So that's another way of looking at it. You could also look at the same thing and understand that a circle could do the same thing. So if the energy goes in and it just gets trapped in a circle, that the same thing is true. The initial energy is still in there. This whole path cancels out itself, but it doesn't cancel out the initial direction. So that this circle would just process in space like this forever. As long as that piece of stuff is trapped, you'll just process in the direction of that little bit of added momentum. So if a meteor hits the Earth, it does have, unless it hits exactly in the center and exactly consistent with the rotation or something, it's always going to add a certain bit of wobble, directional change that's permanent. That has to be undone by another force, has to come along to undo it. It's there until something says change. It doesn't just change on its own or for free. So if you understand the electron and proton could be a trap, an energy trap, then you could understand maybe that what I'm arguing is that when this new force that we've added, so there's all this force hitting all the time and it's pretty much balanced in the universe, but then when two things get in proximity to each other, they change it. And so they have flashlights, they could shoot flashlights and things, do different things to change the environment. And what change means is basically this bit of force, interacts with a piece that's already in the electron, and the interaction is to basically exchange places. So this one stays in, going this way, and this one leaves in here and goes out this way. So you have conservation, you didn't destroy anything, but in fact this thing got a +2 direction change, in the sense it lost something going this way and it gained something going that way. So its overall direction is going to be affected in this rather substantial way, +2. And that looks like it's not conservational, but again, you can look at it and say it has to be conservational, because here's the piece that was in here, and here's the piece that was out here. So all you changed is what was inside and what's outside, but it has a substantial change to the thing itself. So then you can also understand that this thing could have a bunch of changes like that. A bunch of energy comes in, exchanges, with the bits that were already in there, and they're leaving, and it starts getting more and more bits in one direction. And then when you add up its overall direction, you say, yes, it's going very fast this direction. And it could approach the speed of light, in the sense that if you get all of the little bits exchanged, and they're all now going that way, this essentially is just a big blob of force. And you could argue the same is true for something like a gamma ray, photon. This frequency of the gamma ray photon is just so slight that you could almost think of it as a straight line. It's just a bunch of force right on top of each other, and a bunch of these little bits going the speed of light. So like regular light would be this, this gamma ray is very small in terms of it's all compressed and all in one spot, hitting all at once, essentially, very close to all at once. So you can understand that this is really the same as that. It's really the same as getting an electron. This gamma ray is equal to an electron, essentially having all of its bits exchanged, and so now they're all going the same way. They all have the same momentum, and so the two things would be rather indistinguishable in their effect. If I hit you with this gamma ray, which doesn't have a membrane, that's the only thing different about it. It's not held together, as the electron appears to be, but it's just an appearance, frankly. You really couldn't tell the difference between which one hit you. They're going to do exactly the same thing. There are a certain number of bits of momentum. That's all they are. This is bits of momentum, this is bits of momentum, and that's all that's really interacting, are your bits of momentum. So they'd be quite indistinguishable. If this hits an electron or this hits an electron, same thing's going to happen. The exchange is going to take place. The trick is the electron coming towards another electron. Yeah, you can see that. The exchange is going to happen between the force bits. So the force bits between the electron will be bouncing very fast between them. And what they're going to do is the exchanging. They're going to do a lot of exchanges back this way here, lots of exchanges, and this one's going to get exchanges this way. And so they're basically going to take each other's form. This one, all the arrows that are in here will appear to be going in here, and all the arrows in here will appear to be going in here, but they'll be doing it through these little ping pong ball in between that'll be doing all the work. So you just think sort of like the ping pong paddle is made out of stuff, ping pong balls, okay, and you're just exchanging. And so my argument is that this model works for physics much better. It answers all the questions. It doesn't leave you with photons hitting and then having to lose energy, you know, having their frequency or doing some other thing to make the pieces disappear. You know, if you have a photon's energy, you know, like say you have an ultraviolet photon and you attempt to have an infrared one leave, you can see the bit number is different. So you can say, oh, well, this has the less energy, so I've conserved energy because this has less energy. Well, the fact is it has less reality. I mean, it's missing pieces. It's missing volume. And you can't just make that volume disappear. And that's a big flaw in their theory. So is there anything else I wanted to say? So I've mentioned before that the whole thing could just be force, and it's just in a pattern. But I hate to say it, just because it's such a more complex way of viewing reality. It's almost like getting into some nature-nurture argument and trying to dissect the difference between your native disposition and how much that contributed to who you are versus how susceptible it made you to the environmental circumstances that you encountered, just as your height and different things about your life dictated certain outcomes. You know, even the color of your eyes or hair changed the way the world reacted to you. So it certainly had an effect, but you wouldn't call it the decisive thing. You know, it's decisive in the sense that it's a strong contributor to the event being different than it would have been if you had a black hair. But it doesn't get to the root of it. So I'm just saying it gets complicated. But the idea could be is that the universe creates these patterns inside of suns or different places where the force ends up getting consolidated because of the high pressure. And you could argue that once the pattern is created, that is, once you have these arrows very close to each other, moving, okay, in directions, that the external universe maintains this pattern. So once you have them in this close proximity, like they all intersected at the same point, okay, so you have a bunch of energy coming from one place and it all intersects in the same point. That means essentially the next moment they're all going to be leaving the same point. Okay, so they're all going to be doing something like this. And the idea is once you've created this, okay, this little monster, the external universe, if it did have even pressure, you could sort of understand that the external universe, if these things did reflect perfectly, that is, if a head-on collision happens, the head-on collision just produces the reflection. You know, one thing leaves going that way, the other thing leaves going that way. Now, you can't make a universe out of that because you can't tell missing from hitting. I mean, missing looks exactly like hitting. But you can contain something in a structure with this mechanism. So with just a simple feature like that, the external universe applying external pressure means that every arrow that tries to escape hits an arrow, goes back again. Same thing happens. So yeah, one might go a little further, one might go a little shorter, but the end result is going to be is that there's always going to be this apex here, this center. And that's not going away. Unless I really get rid of a lot of this. You know, I have to get rid of something that's happening and I have to allow something to really get far away. You know, before I break this core. So anyway, so that's sort of an argument for the fact that the universe is just patterns of force, you know, and that the patterns can be durable when you put them inside of a universe that's applying a constant pressure. So that might be all I need to start this video. Don't even know if it was necessary to make the point, but I just want you to appreciate that they, just like I, just like anyone, I don't think they have the capacity to tell the difference when the force is very consolidated, that is a very high frequency, that they have any capacity to tell that, to tell the difference between that and a very fast moving particle, okay, electron or proton. If you get one of those two things moving very fast, they're going to behave just like the force. Once you have all the rowers in the boat going the same way, the boat doesn't matter anymore. The rowers are the boat. Okay, so leave us begin.
Now, in our quest to understand what a photon is, we're probably going to come now with this video to the most perplexing thing that a photon can actually do.
So he says it can actually do this. I mean, again, this is just their jargon. They're telling their little religious story, and they're telling us about Jesus's miracles, and the evidence is just as bad. I mean, there's just as little evidence for what he's going to say as there is for Jesus walking on water. It's terrible evidence.
It's probably one of the most perplexing things in the entire universe.
So you're saying something. He's prefacing. He's so uncomfortable, okay, with this extraordinary claim. He won't cite any experiments. He won't cite any reason why they believe this nonsense. And yet he's sitting here right in front of you saying pretty much, this is going to sound really stupid. And yes, I'm not going to give you any reason why we believe this stupid thing, but we believe it. Trust us. You know, this is real. It really happens this way. And it's just a desperate story.
A photon, which is a chunk of energy, a piece of energy.
Yeah, well, so that part's right? The thing called a photon obviously isn't just a chunk of energy. Because, like I said, they'll say right to your face, it takes 9 of them to hit your eyeball for you to see a photon. So it's clearly not a chunk. It's a chunk it's chunks at a frequency. And clearly the frequency has to be there. If the frequency isn't right, you don't see it. So I get, this language is so bad, and they're so confident. And here they can't even notice that their own vocabulary is so fundamentally flawed, because they're calling the little bits that are in the photon, the lumps in the wave, the same thing as the wave. They're just saying, look, any lump, wave. Whole bunch of lumps, wave. They're calling a whole bunch of waves coming into the beach, and they're just saying the beach is wave. They're not even saying waving. So they should call the photon a waveaton, or something, and then call the little bits wavicles. There should be some language that concedes they're not describing it correctly. You can't just point to every single occurrence of wave and just go wave, 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 because they're fundamentally different. One lump is not the same as a whole bunch of lumps in sequence at a frequency.
That has no mass can somehow convert itself into 2 particles that have.
So let's understand, this no mass thing is just another thing they made up, okay? They don't really believe it. As soon as he gets to an equation where he has to talk about what a photon does, they give it arbitrary mass. So, I mean, it's, why are they sticking to this idea that it doesn't have mass but yet has momentum? It's an idiotic notion. Just give it an infinitesimally small mass. So mass is 1. And then your physics might actually work, because then you might figure out then you could measure everything else in terms of its photon strength. Does it have as much energy as a bit that composes a photon?
Mass. Wow. For example, a photon that has sufficient amount of energy, when impacting it on a target, so maybe like a small lead plate or something like that.
Yes, an immovable object. So they're really he's talking about a photon here in the gamma ray sense. So he's talking about a very intense X-ray, you could say, however you want to describe it. But this is a very small frequency, not even a nanometer or less frequency, very small.
if the conditions are just right, that photon will turn itself into two particles. Now,
so there's just no, there's no pictures of that happening. There's no anything. This is all what they surmise is happening inside the lead. This is just their guesstimate, and it's not based on any real evidence of this ever happening. There's just not. And again, let me just point out, they really can't tell the difference between that gamma ray shooting through empty space, let's say, and hitting something, hitting a moon, or an electron of high velocity hitting a moon. They couldn't tell the difference. They have no way to tell the difference. They have no instrument that could tell the difference.
Turns out when a photon turns itself into particles, it's usually a pair of particles, and the one particle is a particle and the other one is an antiparticle.
So this is all, again, stuff they just made up. There's no image of this actually happening. The cloud chamber images they do have sort of indicate some vague notion of it, in the sense that they'll have an image where nothing's coming in, and all of a sudden things are shooting out that they can see. And the argument could be made, well, you don't see the force, just like we don't see photons until they hit something. The photon is invisible till it does actually hit an electron or a proton. And then you see the consequences, because the electron and proton are the things that can create photons. But again, it's all based on something producing an effect that we can see. We can't see all the stuff that really happens, because we only see things where photons are produced. The event has to be rather spectacular, or we don't see it.
That's what we call pair production. So, with other words, an electron can be formed. And of course, an electron is negatively charged, and a positron is positively charged. So we'll form an electron and the anti-electron called a positron. Now, what's the difference between an electron and a positron? Well, it turns out
the difference is one has a so incredibly substantial role to play in atomic structure, and one has absolutely none. So it's like you got a twin brother, you have a complete life, and he has no life at all. He's just sitting on the curb on the street somehow. I mean, it doesn't make any sense. The existence of this positron, it plays no role anywhere. It can't possibly exist because you can't account for it. It has just as much charge as an electron. It's a substantial player. If you put it somewhere, it's going to cause effects. And yet they claim this stupid thing exists, and yet they have absolutely no place to hide it. Where are all the positrons? Where are they? Oh, that's right. They don't exist. Clearly. It's not a real thing.
They're identical in all respects, except one has a negative charge and then one has a positive charge. So this is the electron that we're used to.
Yeah, the electron that's integral to the whole function of the universe, that's essential to exist inside the atom, and the magical positron that somehow I don't have any place to hide it. I already filled my nucleus. My nucleus has already got all the mass it can take in it. I can't shove a bunch of positrons in there. Where are they hiding the magical positrons? Where are they? Where do they come from? So this is what he's made up this story that somehow this gamma ray comes in and it makes these matter bits, and then conveniently, the matter bits annihilate with each other, and so now we don't have to account for them anymore because they disappeared again and turned back into a gamma ray. I mean, this is just made up. There is so little evidence. I mean, the mass of the evidence is less than the mass of a photon.
And there's the positron, which is the antiparticle of the electron. Now, what happens when an electron meets up with a positron? And they meet and merge together. Well, what happens is they annihilate each other, and they will turn themselves back into a photon.
So again, just the storytelling. Now, clearly, as I have argued, there's going to be lots of geometry in reality. Okay, right turns are possible because the two forces act a little different with each other. So I'll just explain it real quickly. The essential difference. The argument is charge is essentially made because there's two kinds of force and two kinds of particle, electron and proton, positively charged, negatively charged. And the trick is, is that they act inversely to each other. And they act inversely to the force, essentially, right? So if I have a yellow force coming into this yellow object, what it's basically going to do is just do this exchange thing. So more likely than not, it's going to exchange with something coming right at it, because that's more likely, depending on the direction it's moving. That might be less likely, but anyway, there's going to be an exchange made. What's in here is going to go out here, and what's in here is going to stay in here. And it's going to be that simple. That's all you got. Now, the more complex one is when the opposite force hits. Its reactions are a kinetic version of that. Okay, so you have two versions of what can happen. The two forces hit each other. Ooh, okay. And, well, let's just make them different colors just for illustrative purposes. So you can understand that they're basically exchanging, and one goes this way and one goes this way on a reflection. You could also understand that that same kind of reflection could take place. That is, you can have two things hit each other, and the equally conservative of momentum interaction would be for them to slide off of each other, like arrows are even convenient for this. And this one goes this way, and the other one goes the other way. So you can have these perpendicular reactions. So this would be two choices of interaction. The choice is a pure reflection or a bisection, where you conserve the momentum by it being pushed into the other dimension, but it's still the same amount of momentum. Okay, so it's conservation of the momentum, but because the universe has 3 dimensions, it's certainly allowed to put stuff in the other 2, without breaking any laws.
Now, what is the energy required to turn a photon into electron and a positron? Or if it was a very high energy photon, you could actually form a proton and an antiproton, or a neutron and an antineutron.
Right, so now they're going to very heavy things, which you'd have to have, so this is another one of their infinite wells, because now they've made the closeness of this force, the fact that you could smash all of these arrows right on top of each other. The gamma ray is a wave so close together that you can't tell it's a wave kind of thing, right? I mean, it's just it's a preposterously, the wave is this, it's up and down in the same place, essentially. So they're basically saying, like, we can pile these arrows right on top of each other, so close to each other that you can't see the arrows anymore because they're so close to each other. So you can get a lot of stuff in that little bit of space. But again, I'll argue that once you've done that, you haven't done anything different than give a regular proton or electron momentum. See, they think the momentum of the proton is its mass has increased. So they think when they give it velocity that they've increased its mass. All they've done is change the disposition of its mass. It now no longer, when it's moving close to the speed of light, it means everything inside of it has now been exchanged, and all the rowers are going in one direction. So it has no drag. It has no rowers going the wrong way to slow the boat down. But it hasn't gained any rowers. It's just that all the mass is in this direction now. All the mass, which would be these little things, the rowers are the mass, all the mass is going in one direction. So it doesn't have any mass this way, and it doesn't have any mass this way. It's not going to, you can't poke it. Okay, you can't feel its weight in the, poking it from behind, because you can never catch up to it. It's going so fast. It has no mass in these other directions. Mass is pressure. Mass is when you push on something. Something about you is pushing, going in a direction. And it's pushing, it's hitting the wall of the cardboard box and banking off of it, You can hear it bouncing in there. That's all it is. Mass is just having momentum in a direction. And when your directions are all the directions, when you have mass, you have force going in all the directions, you're not going very fast. But the faster you're going in a direction, the less mass you have in the other directions. the fewer rowers. It's that simple. But again, they're so sure they're telling you the true story. You know, that this made loaves out of fish or whatever, this fed a zillion people with 4 fish story is a real story. And it, like I said, they can't show you this story. They can't show you any evidence of this story besides the fact that, well, Dirac says so. And, you know, that's good enough for them.
Well, it turns out the amount of energy need comes from the equation E equals mc squared. So what is the energy required to make an electron, and what's the energy required to make...
So this all depends on what your constants are. So as to see, again, if you don't understand what is mass, and like I said, you start exaggerating these masses by saying they have gained extra mass by moving. So that is, they've gained rowers. More people got in the boat. That's their understanding of the physics, and it's just a wrong understanding. You haven't put more rowers in the boat. You've just changed the rowers that are in the boat, and now they're not rowing in the wrong directions. Fundamental misunderstanding.
To make a positron, well, let's plug in the mass and multiply times c squared, and that will give us the energy. So to make one electron, for example, that would be equal to the mass, which is 9.11 times 10 to the minus 31 kilograms. And you multiply that times the speed of light squared, 3 times 10 to the 8 meters per second. You square that, and that will give us the energy required to make a single electron.
So I'll zoom through some of this just because, you know, see, they always ask specific questions that are interesting to them that, frankly, I just couldn't care less, because I want you to explain how that happened. How something called light, force, essentially, was converted into matter. So this is almost like the LIGO people saying, you know, that they converted 3 solar masses into some magical force that isn't photons or radiation or any of that. The magical force is bent space. It turned it into some sort of bent geodesic. You know, there's no explanation of how that's possible. Certainly not something Einstein said you can do. I don't know what Einstein's opinion on this was. I don't think so. I don't think so. I think that would be what he'd say.
9.11 e to the 31 minus times 3 e to the 8 squared equals, and the energy need would be 8.2 times 10 to the minus 14 joules. Now let's convert that to electron volts. So of course...
Yeah, why don't you do that like instantaneously or something, because no one uses this joule stuff. So either everybody ought to figure out what a joule is, or everybody ought to just do auto conversions. They ought to change the other stuff into the same stuff that electron volts requires the other stuff to be in, or something, just to save this stupid step that's done over and over and over.
Of course, to convert that electron volts, that would be equal to 8.2 times 10 to the minus 14 joules, and multiply it times, let's see here, 1 electron volt divided by 1.602. We're going to give it a few more significant figures to get a slightly more accurate value, and that would be times 10 to the minus 19 joules. So it's that many joules per electron volts. So divide this by 1.602 e to the 19 minus, and we get about 512,000 electron volts.
So a preposterously large amount. And again, it just has to do with, now see, they've created this infinity. They can make this stuff get as close as they want to. And there's no, like, physics limitation. And they've assumed, okay, that the energy increases with frequency, when I've sort of pointed out it's a tipping point argument. You're really not making more energy. Yes, there'll be more little bits involved when you're tipping something over, but this goes way beyond any tipping point needed energy to get an electron to move, to create a vibration, to initiate sound, for example. You don't need something to move the speed of light to create a sonic boom. You just need it to move faster than the speed of sound. Yeah. So it's just their math doesn't understand the limitations of the actual physics. That the actual physics is real things, and they can't do this being in the same place thing, essentially. Essentially, in some ways, they're forcing the elements of the photon, the waves, to actually overlap each other. They really can't. You can't make the waves overlap each other.
So that's the amount of energy you need to make an electron. And of course, that would also be the amount of energy you need to make a positron, because the positron is the exact same amount of rest mass. So the energy required here.
So again, they're converting mass into energy in the sense of a direction, as if when it's resting, it's actually moving. You know, as if I could take the fact that the arrows are going in all different directions, and yes, now I can just move them in any direction. So in a sense, they're buying into that argument, when in every other case they'll argue differently, that you have to add mass to have velocity.
Energy for the photon would have to be equal to 1,024,000 electron volts. Now, what if a photon came along that had more than that amount of energy? Well, then the additional energy would then be imparted on the electron and positron in terms of, or in the...
So in a sense, I mean, they're giving this gamma ray so much energy that it could just blow up planets. I mean, it's a tremendous amount of energy they're giving a little bit of radiation.
Form of kinetic energy, and it would fly off at some speed. The more kinetic energy you have, the faster it would be flying away from this particular event. So, what kind of photon has enough energy, this many electron volts, to make an electron and a positron? So here what we can do is we can say, well, the wavelength would be equal to hc divided by the energy.
All right, so I'll just point out again that this whole nonsense, the reason why frequency has effect on electrons is because electrons are in tension. And to move them out of the tension, they go back. So if I hit them with a rock, it goes back. I hit them with a rock, they go back. I have to hit them with rocks quickly in sequence to move them, because they rebound. And the reason why frequency matters for photons is because the tension that the electron is in is different for every molecule, every compound, every substance is going to have a different tension that the electron's going to be in, and you're going to need a certain threshold pressure to move it. Period. And then you have to get that pressure to actually hit, enough electrons in the crystal or whatever you're hitting to make the vibrational movement, to make it move. The whole atomic structure has to move.
Of course, the energy is also in terms of electron in joules right here, so that would be equal to 6.626 times 10 to the minus 34 joules times seconds, multiply times C, 3 times 10 to the 8 meters per second, and divide by the energy for two of these particles, so it would be 2.
So another way you can look at this silly energy argument is that a radio wave has very low energy. So if you did the calculation, it would be pathetically low, because they're basing it on frequency. So they're basically saying that this radio wave photon, is minuscule. I mean, you need a billion of these radio waves to equal one photon of light. By their calculation. So one photon of visible light has a billion radio waves worth of energy. And you could sort of deduce for yourself that that can't be the right answer, because clearly the radio waves travel great distances, and they are able to excite antennas, and we're able to receive, a signal. So it's kind of silly to say there isn't any substance to the radio wave. There's clearly a huge volume of it that's produced, and each little bit of it has the same. If I'm the electron it hits, it's just as real. We see photons from billions of light years away. The photon that hits us is just as real as a photon would hit you if you were 10 feet away. And the only thing you're changing is the number that are hitting you. So when you're hit by it, it is exactly the same amount of energy it was when it left. I mean, it's just, it's just the wrong way to look at it. They made a wrong choice, and they just keep trying to rationalize these bad choices. They keep trying to make positive and negative as frankly, they did change that in terms of changing all of their perspective. But again, it made it possible for them to say current goes one way through a wire and voltage goes the opposite way because of that mistake. And so they just contrived a mechanism to make it make sense, and the mechanism doesn't describe the reality right at all.
times 8.2 times 10 to the minus 14 joules, because we want to do it in joules to get the correct number here. So the wavelength would be, so 6.626 e to the 34 minus times 3 e to the 8 divided by 2 and divided by 8.2 e to the 14 minus equals. And so the wavelength would have to be, lambda is equal to 1.21 picometers, so times 10 to the minus 12 meters. And of course, that photon is so energetic that it falls in the realm of gamma ray, so we'd have to have it.
Right, and it also falls in the realm of nuclear bomb or something. I mean, it's just preposterous to say that it has that much energy. It only has a little bit of energy. I mean, a certain number of little lumps in its wave. That's all it has, is a certain number of lumps. And the fact that they're close together doesn't make it more energy. It just means that it can transfer the energy quicker. And in some circumstances, again, when stuff is in tension, it'll make a huge difference. When stuff's in tension, getting hit by one big clump means you're gone. You're moved out of your atom. You get hit by clump, 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 then you stay. All right, that's all there is here. This is just a tipping point circumstance. It's clearly obvious. It's clearly the correct answer. It's clearly a more correct answer than this nonsense. Frequency dependence does not mean more energy. It just means more in the period of time. That's all. All right, it doesn't mean, you know, that you have an infinite well you can just fill with energy by increasing frequency to preposterous numbers. You can just use some, 10 to the 999th, okay, picometers or something, some kind of preposterous number to say I could just make it infinitely small frequency and now I can make an infinite amount of energy. That's what they're saying. That's what this math leads to, is preposterous things like that. You got to understand how you got to now be able to figure out that doesn't make any sense, that I can't just take a photon and smash all the little bits together, the little waves, and then magically create something that could blow up a universe. Come on. You know that isn't happening.
A gamma ray photon to produce enough energy to create the two particles, but it can do so. Now that's quite
says you. So he just says so. It can do so. This is real. This is like talking about trees outside. Trees are real. Bushes are real. All this stuff is real. No, they don't got no picture of this tree, no picture of this bush, no references to any kind of genetics or any like it ever existed. There's nothing. They have cigar photos of their UFO. This is extraordinary claims being promoted as fucking as some kind of proven fact by a whole volume of evidence, and there is none. There's silly Diracian equations, and that's all there is.
amazing. Here we have a particle that moves at the speed of light. It has no mass, just energy. And
so again, a lie, just an overt lie, right? Because they'll say it has no math, but as soon as they put it into a mathematical equation, they're going to give it an arbitrary math. They're going to play this game and say, well, because it has this KC stuff and because it or HC and it has a wavelength, therefore it must have a math. I'll just make that equal to its mass. And so they're forcing that to be momentum. They're saying frequency is momentum, essentially. And then that fixes their momentum problem because momentum really is velocity times mass. And so they just changed that by saying, well, I'm going to replace mass with HC over lambda and just say that that's the same thing as momentum. So that's the danger of mathematics, is this replacement. You take one thing and you just say it's the same as another thing, and it's not the same thing. Bogus.
it impacts in on a target, causing it to change itself into two particles that actually have mass, one particle and one antiparticle. And then when those two come together, they annihilate each other and form back into a photon of the energy released equals mc squared for both particles.
Yeah, it just magically goes back in. So this is their story, right? So they're telling you a gamma ray goes in, creates two particles. The two particles annihilate and recreate the gamma ray. And what do they have as an experiment? Well, a gamma ray was here and a gamma ray came out here. They're just making up all the stuff that happened in between. It's just a story.
Just an amazing thing. How can a photon do that? Well, we don't know. We know that it does.
Yeah, we know that it does. And that you won't explain in any of these videos how you know that, how you're so frickin' sure. Why do you know that? I don't think you know it for any good reasons.
Just gives us another look, another window in understanding what a photon actually is.
Right. You just said it's pretty preposterous, pretty hard to believe, pretty amazing, pretty nutty. We could use all kinds of vernacular for how sure you are this is bizarre. And yet you say, yeah, look, doesn't it make it all easy to understand the bizarreness? Isn't that, part of the fun? No, it's what makes this physics nonsense. Extraordinary claims, less than ordinary evidence. And that's what you've got. And nobody honest, nobody with any intellectual integrity would say otherwise. You can't possibly have intellectual integrity and say, oh, the evidence is voluminous. The evidence is undeniable by a reasonable mind. No reasonable mind could conceive of any other alternative explanation. It had to be Jesus walked on the water. There's no other explanation. We have the footprint in a wet towel that he used to dry his foot with. Yeah, okay, carbon dates to 3 years ago, but that's, carbon dating is bullshit.
So if you're still interested, stay tuned and we'll take some other looks at what a photon can do, how to experiment. We've understood the photon better and better, and eventually we'll be able to form a really good picture of what a photon is.
You won't be able to. You're so wrong-headed. You're never going to make a good picture of your bent geodesic. You're not going to make a good picture of your virtual photon. You're not going to make any good picture of this idiotic notion that momentum is the same as frequency, that energy is frequency. It's just plain wrong.
And that's how we do it.
Okay, so that one wasn't much fun. Okay, comments kind of thin, which is good. Ended up reading a bunch in the video that broke the other day, so that was good. I got rid of them without, I did respond to your comment. It just was in the video that got destroyed. Alright, great video. There you go. Is there a way to prove this, e.g., by measuring the energy in the experiment or by manipulating the amount of electrons that are affecting the light passing through the slit? I'd argue that they've already got every indication of a proof against it, in the sense that their math doesn't fit the pattern. Okay, it's just a fact. The pattern is bar-like in photons. And they'll keep showing you electrons. Oh, look, electrons, look at the pattern. Because the electron pattern is on and off very gradually. Because it's electrons. Electrons bounce off of each other. They don't hit each other. They bounce off each other's fields. So of course, they're going to be blurry in terms of their directionality. But anyway, so the photon experiment doesn't fit the math. Just doesn't. And you can see in the photon experiment, when you start making the slit very, very narrow, you can see the roundness, okay, of the laser beam in the vertical direction. You can see they get round. Okay, that's an image of the top and bottom of the laser beam. That's what that roundness is created by. There's no mathematical reason for the roundness. The roundness is an artifact of the fact that it's a round beam you're putting through, and the slits are higher than they are wide. So the whole laser beam goes through the vertical part, and so you're seeing the round edge. And they could just do this simple experiment. Take the slits and don't make them quite as tall, and make the beam go above the square of the top of the slit. And guess what? The roundness disappears. So, and then you got the multi-slit, the diffraction gradient that's shooting images to the location. Images are going to the images of whatever beam you put in. I put Daffy Duck, an image of Daffy Duck, into a diffraction gradient. I get an image of Daffy Duck at all the locations. That can't happen with wave interference. So there's already evidence right there in front of them. This is just like the lensing argument. There's already evidence right in front of them that it doesn't make sense. The Einstein rings are way too thick. There's no theory for them to be huge, gigantic. All right, there'd be no way to get detail. That is, you couldn't see little stars in a galaxy in a lensed image, because theoretically there'd be no way consistency in the image. It would be just complete distortion. It would be much worse than a funhouse mirror image. So if you got any light, it wouldn't be any light that had stars in it in different locations and any coherency. So that's evidence. The fact that they know there's a ton of gravity out there in space, and that all the photons would be deflected all over the place by all of that gravity if this was a true theory. If light was actually bent by gravity, we wouldn't be able to see photons from another star in anything called a coherent location. Everything would be lensed all over the place. So there's already enough evidence to debunk their theory. They just don't care, clearly. All right, but yes, I would like to come up with some experiments. I mean, I think, as you make the slits thicker, like if you made a tunnel for the light to travel through, different things you can do to point out how these effects aren't consistent with a wave theory. They're consistent with this idea that the photons are actually hitting particles, electrons. All right, so what else can I say about it? Yeah, so I do want to think of some experiments to do. But I'm like I say, the evidence is already there, and they pay no attention to it. The indication that they're wrong is already there, and they just couldn't care less. Manipulating the amount of electrons that are affecting the light passing through the slit. Yes, and receiving the energy is sort of an interesting concept, right? I mean, the fact is I'm basically saying the dark spots are being hit by energy, and they probably are creating a thermal image. So maybe they could use thermal technology, right, to see, shoot it onto a black surface and see what you get in terms of a pattern. There might be different ways to see that you dull it, or it's less distinct, the pattern. Some other kind of thing would give you an indication that there is energy hitting those locations. It's just not in the form of visible photons, visible light. Unfortunately, like I said, it is all going to turn into heat in a way. Gravity is essentially heat. Everything's going to create heat. I mean, you can't get away from the heat component of the little bits, the force. So it really can't interact with something without heating it up, just the way the Earth is molten to center. It's gravity that's causing that, right? They don't tell you that, but that's why the Earth is melted in the middle. It's because it's got a lot of bits going this way and a lot of bits going that way. It's got a lot of stuff moving in a direction. All right. Yeah, so that's probably enough. So, yeah, working on it. But like I said, I've already done some experiments where I showed how a dirty piece of glass creates the same pattern that the interferometer creates. It being a clear indication that, this doesn't have anything to do with the photons interfering with each other after they come out of the experiment. It has to do with the fact that the photons were interfered with by the beam splitter. All right. So, I tell you, this is like I said, this shouldn't be this difficult. It really shouldn't be this difficult for a human being on Earth to raise his hand and say, I think you've made a mistake, you're kind of thinking wrong. And especially in a circumstance, like I said, where they have these hard conclusions based on the scantest evidence. I mean, the evidence is so frickin' thin. It just, you wonder, if Darwin had done a lot less work, would these people believe in evolution? Because they would they believe even if there was no evidence? I mean, what's their standards for asserting something to be a truth in terms of evidence? Because apparently they really just don't need there to be much. Any. And it's another bad religion. I guess that's the other story I would say, is that you understand, okay, people could make up a story of truth, and you could sort of understand making up a lie that was fun, like the lie that you have a heaven. I mean, that's a fun lie, right? In the sense that, I'm going to go someplace better than this and have a good time. But then they describe heaven so badly that you're like, why would I want to hang out there? Right? I mean, a bunch of rubies around. I'm not interested in rubies. I'm going to heaven. What do I need money and rubies for? I don't need any of that shit. They don't describe what you do there except sit around, watch Jesus molest children or something. I mean, there's just nothing to do. No description of a fun event, the orgy or anything. So it doesn't seem very appealing, right? Where I would say, well, if I'm going to make up a truth, yeah, I'll make up something appealing. I'll put the orgies in there and all that stuff, and you have, you can become a professor of orgy. You can do, all kinds of fun things. But anyway, where was I? Yeah, so you can understand making up stories when, but see, that's how religion fails. I say, how could religion be successful? Because it's a shitty story. I don't want it to be true. Okay, I don't want there to be a God and all that crap because it sounds like prison. Sounds like just heaven sounds like prison. I don't want to go to prison forever. Everybody's watching what you're doing. You can't have any fun. Fuck it. Completely unappealing as a fable, right? And I'd argue that their physics is just as unfun as a fable. I mean, it's full of paradoxes and contradictions and nonsense and rubbish. There's nothing fun about this lie they're telling. And you're saying, why are they so devoted to it? Why are they so devoted? Oh, entanglement or some kind of nonsense. You're saying, what are they getting out of that? How are they jerking off to this? Because I can't see it. I just can't make it possible. But anyway, that's all. I mean, it's but so it's just as bad as religion in the sense here they are making up a story. And it's a crappy story. It just sucks. Yuck. Anyway, till the next time. Such. All I can do is reason with you, right? I have attempted to reason with you. I can't make you reasonable. I've made a reasonable argument here. The one I've made over and over again is that the evidence is pitifully weak. And that part you should all be able to agree with. You should all be able to say, okay, I concede the evidence sucks. We still like this a lot, though. But just admit you don't have evidence for your little UFO story. See, they're telling a story like, okay, we're really all from Venus, and the Venetians transported us here 50 billion years ago, and blah, 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 some kind of bullshit story. And it's, there's just no evidence, but they really want to believe, and why don't they just fess up? All right, so till the next time.